In this video, I briefly talk about some concepts relating to magnetism, which is relevant in an undergraduate physics introductory class. Firstly, I want to say that a compass is a small magnet that rotates and experiences magnetic field. And when we keep a compass in a space where there's magnetic field present, it tries to rotate and lines up with the magnetic field. We will see what is a magnetic field shortly. Also, magnets produce magnetic field around them. Additionally, magnetic fields are also produced by current carrying wires, current loops, and current coils. And sometimes the current coils are referred to as solenoids. The presence of magnetic field can be detected by putting a compass at a point of space where we want to detect magnetic field. If magnetic field is present at a point in space, then the compass's north pole will always point towards the direction of the magnetic field at that point. Also, it's interesting to note that the presence of magnetic field at a region in space results in a magnetic force that acts on a moving charge when the angle between the magnetic field and the charge, moving charge, is not 0 degrees or 180 degrees. So there is a name for this magnetic force, which is referred to as the Lorentz force. In addition to moving charges experiencing Lorentz force in magnetic field regions, magnetic force is also experienced by current wires, because remember, current wires are charges moving inside conductors. Additionally, for starting similarity with electric field lines, magnetic field lines are used to visualize magnetic interaction between magnetic materials. Now we will talk about some common properties of magnets. Well, first we'll define what a compass is. A compass is a device which consists of a freely suspended small magnet. So in this device, a small magnet is pivoted so that it can rotate freely, and each compass has a magnet which in turn has two poles, north and south. And interestingly, the north pole of the compass points towards the Earth's geographic north, which is the Antarctic. Magnetism is a long-range force. What that means is that magnets need not touch each other to exert a force on each other. All magnets have two types of poles, north and south, and we know that magnets exist as dipoles, so it's not possible in nature to have magnets which have just one of these poles. In fact, we are not able to manufacture also such magnets having just one pole. These are important because we know that two magnets will attract each other if their unlike poles face each other, and two magnets will repel each other if like poles face each other. And not all materials experience magnetic forces of repulsion or attraction. Only some materials, which are referred to as magnetic materials, can experience magnetic forces. And the direction of the magnetic field or the magnetic force is given by the direction of the compass's north needle.